everyone and welcome to all of you. Dear students, in previous lecture we have already discussed the test of significance and the concept of testing of hypothesis, null hypothesis, alternative hypothesis and a critical region, level of significance and degree of freedom. In previous lecture we have already discussed the steps involving in the testing of hypothesis. So today I will discuss on the topic of test of significance based on the Z or normal test. So in this section we will discuss test of significance where the sample size are large. Okay, sample size are large. Dear student, any statistic we use this formula for testing. Suppose like a Z or T or F or chi-square. Any test statistic follows this formula. Statistic minus parameter divided by its standard error. Standard error. What is standard error? Standard error is the standard deviation of its sample values called as standard error. Okay, and standard error formula standard deviation divided by under root n. It's a standard error of population. Suppose standard error of sample mean is s divided by under root n. Okay, so now we discuss the first test is Z test, Z or normal test. What is Z test? Z test is the ratio of difference of mean and its standard error. Okay, Z test is the ratio of its difference of mean x bar minus mu divided by its standard error. Okay, in the Z test, two conditions. Suppose this is the population. If we draw one sample from this population, here the parameter mu, sigma, etc. and the statistic x bar and s. So if we draw one sample from large population, so one condition of Z test and second condition of Z test, if we draw two samples from one population and any other condition, the two samples drawn from two different populations. So here the formula use x bar 1 minus x bar 2 in this condition. Okay, where x bar 1, this x bar 2. If two samples drawn from the one population, x bar 1, x bar 2. So this formula use under root sigma square divided by n plus sigma 2 square divided by n2 n1. Okay, and here sigma under root n. Okay, if the two samples are drawn from same population, then its modified formula x bar 1 minus x bar 2 divided by this and 1 by n1 plus 1 by n2. Okay, this is the variance. Okay, standard what is variance? The square of the standard deviation is called as variance. Okay, so now see the problem based on the z test. Okay, dear student, let's see the example. A sample of 100 member has a mean 6 is the sample from a large population of mean 6.4 and standard deviation 3. Dear student, in this example, we give x bar equal to 6. X bar means sample mean. Okay, and large population of mu is population mean 6.4 and standard deviation, population standard deviation sigma equal to 3 and sample size n equal to 100. Okay, now first we set up the null hypothesis. Null hypothesis H naught here x bar equal mu. It means that our sample are drawn from population, that is sample mean is equal to population mean. Okay, now alternative hypothesis x bar does not equal to mu, that is sample mean does not equal to population mean. Okay, third step, compute the level of significance. Dear student, all agricultural conditions level of significance is 5%, mostly 5%. Okay, now formula of z test, z equal to, in this condition, first condition of z, population standard deviation are known. Okay, and second condition, sample size n is greater than 30. Okay, this condition also follow. So in this condition we use first formula of z test, x bar minus mu divided by sigma divided by under root n. It's follow normal distribution 0. Why use this formula? Here only one sample drawn from the large population. Okay, since population standard deviation are known and sample size n is greater than to 30. Okay, now x bar equal to 6, mu equal to 6.4 and sigma equal to 3 and n equal to 100. Now put the value in the formula. Z equal to x bar 6 minus mu 6.4 divided by population standard deviation 3 and 100. Okay, now solve it. 6 minus 6.4 equal to minus 0.4 divided by 3 under root n. Under root n is 100 or under root 100 means 10. Okay, now 0.3 and here minus 0.4. So here point cancel. Now 3 and the 1.33. So this is the Z calculated value. Okay, now next step is what is Z tabulated? Z tabulated value in the Z test, Z tabulated value in 5% fixed 1.9% and 5% level of significance 1.96 and 1% 3. So the conclusion is that if Z calculated value is greater than the tabulated value, so null hypothesis is rejected. If Z calculated value is less than to Z tabulated value, then null hypothesis accepted. So in this case, our Z tabulated value is 1.96 Z tabulated and Z calculated 1.33. So we can say Z calculated value is less than to Z tabulated value. So conclusion, we write the conclusion. Conclusion, Z calculated values less than to Z tabulated value. So null hypothesis accepted and H1 rejected. So we can say the sample are drawn from population and this is equal. Okay, so this is the example of one sample drawn from the population. Okay, now next we see that the two sample are drawn from one population. Okay, let's see, dear student, let's see the second example. Here the means of two large sample of 1000 and 2000 member are 67.5 and 68 inch respectively. Can the sample be regarded as drawn from the same population of standard deviation 2.5 inch? This condition is second type condition of Z test, where where two sample are drawn from same population, only one population. So here the standard deviation only one. Okay, so use this formula, Z equal to x bar 1 minus x bar 2 divided by standard deviation multiplied by 1 by n1 plus 1 by n2. Okay. Now first we set up the null hypothesis. Here the null hypothesis is not equal to H naught here x bar 1 equal to x bar 2. It means that is this both sample are equal. Both sample are equal. Okay. Alternative hypothesis is that x bar 1 does not equal to x bar 2. That is both sample are does not equal. Okay. Now in this case we have x bar 1 equal to x bar 1 equal to 67.5, x bar 2 equal to 68, and n1 equal to 1000, n2 equal to 2000, and standard deviation, population standard deviation 2.5. Now X bar 2 equal to 68, n1 equal to 1000, n2 equal to 2000, and population standard deviation is 2.5. So put the value in formula. Formula is here z equal to x bar 1 minus x bar 2 divided by standard deviation 1 by n1 plus 1 by n2. Now put the value in formula. X bar 1 is 67.5 minus 68 divided by standard deviation 2.5, 1 by n 1000 plus 1 by 2000. Now 0.5 minus 0.5 divided by 2.5 multiplied by, this is calculate, but we can direct written 0.0387, and next minus 0.5 divided by of 10, 2.5 multiplied with 0.0967. Then after that minus 5.1. So this is the Z calculated value. Okay, this is Z calculated value minus 5.1. Now we use tabulated value. Z tabulated value is 1.96. Okay, so if you compare, so Z calculated we can written in mode में, जो है mode Z calculated equal to minus 5.1. Compare this 5.1 calculated value is greater than to Z calculated value. Sorry, Z tabulated value 1.96. So we can say that null hypothesis is rejected and alternative hypothesis accepted. So conclude that there are both sample mean are not equal. Okay, uh, there both sample mean are not equal. So this is the conclusion. Okay. Now we write a conclusion. Conclusion. Z mod Z calculated minus no 5.1 greater than Z tabulated 1.96. So it is highly significant. So in this case null hypothesis is rejected, and we can say the both sample are not equal, both samples are not equal with standard deviation 2.5. Okay, so this two types of condition. First, where one sample drawn from the one population, and two sample drawn from same population, type two condition are solved. So okay, thank you.